Okay, so here we go. We're going to do section 7.2, and we're talking about things that I'll just put the word out here already. We're going to talk about similar polygons. So similar is really the key word to what we're going to do the rest of this chapter. Let's talk about what similar is. Now, basically, we've talked about something that was kind of close to it. We've talked about congruent. So a lot of times people compare the two words. Now, if I said two things were congruent to each other, not just triangles, but anything, if something was congruent to each other, I could take one thing, pick it up, and put it right on top of it. It would be exactly the same. So, for instance, let's make a triangle. I'll just make one from scratch here. So, there we go. There's a nice little triangle. Let's group them so I can do something with it. Alright, so there's a triangle. Now if I said a congruent triangle, what would I do? I would copy and I would paste. Alright, and I didn't change anything. It's exactly the same triangle. I could even, let's do this. I could even rotate it. By rotating it, does that change whether it's congruent or not? No. I could flip it around. I could do all kinds of stuff with it. Now if I start changing the shape of it, then it won't be congruent. If I change the size of it, then it won't be congruent. You follow me on this? Alright, but let's go back to this. Let's talk about similar though. So we know what congruent is. We had a whole chapter on congruent triangles and congruent polygons. But watch this. What I'm going to do is I'm going to click on it. I'm going to hold the shift key. Now if you know anything about like graphic design on computers and stuff like that, if you hold the shift key, it keeps everything in, what's the word? We talked about it in the last lesson. In proportion. Very good. Okay, we keep it in proportion. So by keeping it in proportion, if I hit the shift, well, I tell you what, let's do it without the shift key. If I take this and I moved it around, look at that. It didn't just change the size of it, but it also changed what? The shape of it. Exactly right. So I changed the size and I changed the shape. So that really doesn't have any similarities anymore to this triangle right here, does it? Okay, but watch. Let's go back to where I was. If I hit the shift key and I grab a corner, and then I drag it, look what it does. See, I'm moving it up and down, and it's not changing the shape at all. What's it changing? Just the size of it, okay? So that triangle right there looks really, really close to this. Or I could take this one and I could shrink it, make it really tiny. They're basically the same shape, aren't they? Not basically, they're exactly the same shape. What did I change, though? I changed the side. So if they're the same shape, I'll tell you what, let's make this a little bit bigger so it's a little easier to work with. I'll keep them different sizes, but watch this. This angle right here, did I do anything to change that angle? Even though I made the whole triangle bigger, does that mean I changed the angle? No. This angle right here and this one right here are still exactly the same. This one down here and this one down here on this big triangle, they're exactly the same. All right, just because this triangle's bigger doesn't mean the angles are necessarily changed. And then you've got this angle down here in this corner and this one right here. So look, in order to have similar polygons, now I drew a triangle, but this could work with any shaped polygon. It could be 4, 5, 6 sides, whatever. It doesn't make any difference. I just picked a triangle. If I have all the corresponding angles equal to each other, if all the corresponding angles are equal to each other, then we call it a similar polygon. Okay? If all the corresponding angles, if I took this, picked it up, matched it up with this, now it's not going to be able to sit on it perfectly, okay, but if I took a look at it, watch this. This is kind of cool with this program because I wasn't able to do this with a just a regular chalkboard or a whiteboard. Watch, if I took this right here and I picked it up and I put it right there. Now would you agree that that angle is exactly the same? Right? This angle down the bottom is exactly the same. If I picked it up and put it up top here like this and put it right on top of it, look, that angle right there is the same. And if I picked it up and put it down here like this, okay, that angle right there, see? It's got the same exact shape, doesn't it? But what's different? The sides. The lengths of the sides are different. But guess what? So there's one thing we know about similar polygons. Again, this works not just for triangles, but this works for all kinds of polygons. All right, I could have done a 4, 5, 6-sided figure if I wanted to. So there's a couple things that are true. Let's get rid of that word congruent because we're not really going to discuss congruent. If I had a similar polygon, there's two things that are true. Okay, we'll say this, that the corresponding angles are equal All right, so just like I did, I picked one up, put it on top of the other ones. The ones that match up with each other, those angles will equal each other. So the corresponding angles are equal. What do you think is true about the corresponding sides? Like this side right here, see how it's opposite the 2 arc? And this side right here, it's opposite the 2 arc. Are they equal to each other? Do I put one tick mark here and one tick mark here? No. But let's do this. And I'm just making this up. Let's say the length of that is 4. Let's just say, I don't know if it's true or not, but let's just say that this triangle is twice as big as this triangle. Okay? So if this side is 4, then what's this side going to be over here? This is going to be 8. That's right. What if this side was 6? Okay, I'm just trying to think if my numbers will work right. It's not going to be to scale, but that's okay. What if this was 6? What can I say about this little side right here? See how this side is opposite the 1 arc? See, this side's opposite 1 arc. This side right here is opposite the 1 arc. If this triangle is twice as big as this one, then what's this side going to be right here? It's going to be 3. Now again, this is not to scale whatsoever, but let's just say that this is 2. Then what's this remaining side right here going to be? This is going to be 4. Does that make sense to you? So what is the what's the ratio of the corresponding sides? I started off with this being 4 and this being 8. So what's the ratio of the smaller triangle to the bigger triangle? It's what? It's 4 to 8, isn't it? Do you see that? Or if I reduce it, what is that? 1 to 2. Thank you. Got a couple people alive. That's good. You're waking up. So 4 to 8 is 1 to 2. Look at the other sides too. Look at this. This is 3 to what? 6. What does that reduce to? 1 to 2. What about this? 2 and this is 4. So what does that reduce to? 1 to 2. All right. They all reduce to 1 to 2. When you have your sides like this, we call this the scale factor. Scale factor. That's a very important fraction right there. It's a very important number to find. I'm not sure if we're going to do a whole lot of that in this lesson. I can't remember. I'll have to look ahead. Yeah, we do. All right, this is where we do scale factor. So that would be your scale factor. It's 1 to 2. Make sense? Okay, so that means for every 1 you go on the small one, you're going to go how much? 2 on the bigger one. You got it? So if this side right here, I'm just making this up, if this side right here is 15, let's say, what would this side right here be? It'd be 30, okay, because the ratio is 1 to 2. Everybody, you okay with that? All right. So there's 2 things that are true. Let's get back to this. The corresponding angles are actually equal to each other. They're exactly the same. All right. If this is 30 degrees, this is 30 degrees. This is 120 degrees. This is 120 degrees. Everybody, does that make sense? But the sides are not necessarily the same. But we can say this about the sides. The sides are in, give me a word, we said it earlier, proportion. That's right. Okay, the sides are in proportion. Now when we say they're in proportion, they must have the same scale factor, if you want to jot that down in your notes. To be in proportion, they got to share the same scale factor, and they do. 4 to 8 is the same as 1 to 2. 2 to 4, 3 to 6, they're both the same as 1 to 2. So they all have the same scale factor. If they have the same scale factor, then they're in proportion. Okay? Now I kind of showed you with this triangle, but I thought I'd show you another way too with, you know, I'm into photography and stuff like that, so I thought I'd put a picture up here and we'll see how this works. I just want to show you a common mistake a lot of people make, and it's kind of a pet peeve of mine. So let me find a picture first. Alright, so I talked about being a photographer, so let's put a picture on here, and this is what a lot of people do. They'll see, I don't know, let's do this. Let's draw a little, I don't know, maybe you're doing some kind of project or something, and you know you need pictures on the project, and you're like, okay, I got this picture, but this is the space on my project. I want to fit it on this space. Maybe that's the front cover of your, you know, your little, I don't know, what would you call it? Your book, your memory book or something like that. Okay, maybe you're doing some of it on the computer, and this is the shape, right? And you're like, okay, I want to take this picture, I want to put it in this shape. Well, this is what a lot of people will do. They'll put it in here. Oops, let's put it like this, and they'll just drag an edge, put it like this, and then put it like this. And you say, oh, it fits perfect, isn't it? Okay, but look how weird that looks. All right, that doesn't look right, does it? They're all tall and skinny now. Okay, maybe if you want to lose a few pounds, maybe it might make you look a little skinnier and you want to do that, who knows. But that's not what do we say? That picture is not in what? proportion. Okay, it's not in proportion because we tried to put something that was longer width-wise than it was height-wise into something that's longer height than width. Okay, so there's no way you're going to fit that into this spot right here and keep it in proportion. We do that on yearbook all the time. So if I was going to put something, let's get rid of this. Let's go back to that original picture. Look, what would I have to do on yearbook? Well, I'd have to do a couple things. First of all, I wouldn't be able to fit that whole entire picture in that spot and get everybody in there, would I? You could say, watch, if I hit that corner and I hit the shift key, that keeps everything in proportion. You could do this if you wanted, all right, and then maybe put some writing down there, put your, your title or something like that. But you don't want to fill up the space. You don't want to try to put something horizontal in a place that's vertical. Now, we do this a lot in yearbook. Maybe we don't want all three people in it. Maybe we just want maybe I just want Alyssa in it. Okay, so I might do this, and just we'll put. Well, anyway, you get the idea. Maybe I can, I can crop it. Of course, let's put. I think I can move this to the front. Can I do it on here? Arrange, move to front. There we go. Okay. So watch, I can take this rectangle and put it right there, and you're like, well, I still don't have her all completely in there, so let's make it a little bit bigger. This is what we mean by cropping. We do this all the time in yearbook. All right, and there you go. And now I've got that spot right there, and now I just have Alyssa in that spot, and I cropped everybody out. But I kept everybody in proportion. That's the key. All right, so proportions are very important. They're very, very important in photography, and of course in geometry we're going to do quite a bit with proportions. All right, so let's do
How would you fit the whole thing in there?
like I did earlier. I just have to leave some space, or like on yearbook, if I have a certain picture that I really want to go on there and I have a vertical space, maybe I'll rearrange the layout, so I'll make that space horizontal so I can put it in horizontal. So we do that a lot on yearbook. Let's do an example right here. Alright, here's our two polygons, and they're similar polygons. I'll show you the, you know how you had the symbol for congruent, you had an equal sign and then what? A little squiggly thing. Well, just a squiggly thing by itself is the symbol for similar. Alright, so this is what they do. They call it ACDF is similar, so it's just a squiggly thing, no equals this time, because they're not congruent. They're obviously not congruent. This one's way bigger than this one, so they're not congruent, but they are similar to each other. So it's V, W, and YZ. Now that right there, it seems like, big deal. All they did was just rename all those letters right here, but that is a big deal because it tells you which angles are equal to each other. So you know what I'm going to do right off the bat? I'm going to mark the angles that are equal to each other. All right, so A and V are equal, so A and V. See how they switched? And then C and W, D and Y. Instead of drawing 4, we'll just say that's one without any arcs. Is that all right? Now, they tell you something else. They tell you that that length is 12, that this is 9. They call this one little x right there. This one is 6, 10, and 3y minus 1. Alright, here's the deal. This is a little bit different than congruency. Congruency was actually a little easier because you just saw what sides were equal to each other and you just set them equal to each other. This one's a little bit different because the sides are not equal to each other. What's the phrase I've been using? The sides are in what? Proportion. Okay, so we need to figure out a scale factor. Remember, all of these sides, if I match them up, are going to have the same scale factor. So what I want to do is I want to find the same scale factor. Well, let's see what I know. I know this side is 12 and this side is 9. Let's see if either one of these sides match up or correspond to one of these sides down here. Let's take a look at the 12. 12 is AF. If you're not really sure what we did, if you're not really sure if we flipped it or which way we twisted it and all that kind of stuff, look, AF. Come over here, AF. It's the first one and the last one. So which one down here matches up with AF? VZ. So it's this one right here that matches up with VZ. Everybody see that? So 12 goes along with the 3y minus 1. So really, I can't find a scale factor with that. What I'm trying to do is I'm trying to find two sides that are in proportion, and we're going to figure out our scale factor, or the two sides that are corresponding to each other. I want to find the scale factor. What about CD? Come over here. CD, it's the two in the middle. So what corresponds to CD down here? WY. So where's WY? It's this one right here. So what's my comparison? I know this side is 9, and I know this corresponding side is 6. So my scale factor, I'll call it SF for scale factor, is what? It's 9 to 6. See what I did? I found the two sides that I actually know the lengths of. Okay, there's no x's or y's. I actually know the lengths of both of those sides, and I set it as a scale factor. Make sure you don't go 12 to 6, because a lot of people would look at this and say, oh, the 12 and the 6, they go together. But that's not true. We saw that already. So the 9 and the 6 go together. Let's reduce that scale factor. If I reduce that, that's 3 to 2. So my scale factor is 3 to 2. That's a very important fraction that I'm going to use here. So now what do I want to do? I want to solve for x. I want to solve for y. So let's solve for x. Now, which one of these sides is corresponding to this side x? Well, FD. Again, look over here, or DF. DF corresponds to YZ. So the 10 corresponds to what? I'm sorry, I gave it away. The x corresponds to what? The 10, right. So this is what we're going to do. Let's do this right here. So what I'm going to do, if I compare x to 10, because they correspond to each other, remember, all the sides have the same exact scale factor. So x to 10 is also going to be equal to what? 3 to 2. Right. I set it equal to my scale factor. So I take the corresponding sides of the thing I'm trying to find. I'm trying to find x. So I find the proportion there, or the ratio of those two sides, and I set it equal to the ratio of my scale factor. Does that make any sense? So I'm trying to find x. So I say, well, what side does x correspond to? Well, FD and YZ correspond to each other, so I go x to 10. Well, what does that equal? It equals my scale factor, 9 to 6. All right? And now look what I can do. I can do cross multiplication, and then I can solve for x. So, or you can just multiply by 10, but we'll do it like this. Watch, 2x equals 30. What's x equal to? 15. All right? So that's what this side is right there. It's 15. You with me? Let's do the same thing, but let's solve for y this time. We can use the same exact scale factor, because remember, if I set these two sides equal to each other, we're going to get the same exact thing. We're always going to get 3 over 2. So let's do this. Which one corresponds? We're going to solve for y this time. Which side up here corresponds with this, with VZ? Well, VZ. It's the first and the last one, so what? AF, the 12, right. So I take the same, let's do it like this. Let's go, we're going from big to small, right? So let's go 12 to 3y minus 1. Everybody see that? Because they're the ones that correspond to each other. That equals my scale factor. My scale factor is the really important part of doing this. So it's 3 to 2. Again, make sure you do it in the right order. I went from the big one to the small one. You see it? Equals the big one to the small one right here. And now I can cross multiply. Give me just a second to finish this up. Watch. I can cross multiply. So it's 3 times 3y minus 1 equals 12 times 2. I'll let you do the work on that, and then y is equal to 3. I'll let you do the work, okay? So y is equal to 3. And that's basically the kind of stuff that you're going to do in here. Let me give you some problems, and then you can do those tonight. So it's section 7-2. It's pages 469, 470.
Sierra Long, Nancy Harris, Evan Moore, please report to the guidance office.
I break them up a little bit.
Please report to the library.
So write them all down, because you won't be able to memorize this. I don't know why I'm writing on my side, but there you go. All right, so it's 8 to 15, 18 to 21, and then 23 to 26. All right, have fun with that.